There are more integration questions. Um, you can think of some sort of a substitution for the first one, of course. The first one looks like it can use a sine theta substitution. Why? Well, let's see. So it's going to be 2 sine theta dx is equal to 2 cos theta d theta, and if you apply the substitution you'll actually see that this becomes 4 minus 4 sine square theta square root, and dx will become 2 cos theta d theta, and then you can actually remove the 4 and take 2 outside. 1 minus sine square theta, and there's 2 cos theta d theta. 1 minus sine square theta is cos square theta, and the square root of that is cos theta. So you have 2 cos square theta, something like that. There's another 2 from here, so it becomes 4 cos square theta. Okay, so of course you can do this using the double angle identities. I think you can use this cos 2 theta equals 2 cos square theta minus 1. If you use this, you can substitute this as cos 2 theta, and of course remember to change domains, the limits, because you're changing the domain of the functions that you're evaluating. You should accordingly change the limit, so you can do that. Now let's look at the second question. A similar sort of a diagnostic would apply here. Of course, you see these two terms are easy because they're simply algebraic, like this. Nothing special about them. These would apply to a simple power rule. What about the first term, which is e to the x divided by 4x squared? So our question reduces to actually solving this one. How do you solve this? Now we can try solving it by parts. So it's going to be 4x minus 2. Well, let's just remove the 4 for now and think how can we solve this. Okay, we can use by parts, and by parts dictates such a sort of chronology to follow in terms of the sequence of functions: inverse, logarithmic, algebraic, trigonometric, and exponential. Exponential functions are always the last ones, so we can use this formula that we know of, minus u prime v dx. So what happens is the first function, and when both the functions are multiplied, we can expand that multiplication as such. Okay, so let's try expanding the multiplication as such by keeping x minus 2 here, and then e to the x would come, because it's left alone, and then e to the power x. The good thing about e to the power x, you take its integral, it would come back as it is, so it doesn't change under integration. Now if you take the derivative of x to the power minus 2, that would make it x to the power minus 3. Okay, the power rule dictates that one power will be decreased. I'm just skipping over the constants to keep it a little simple. Okay, so that is going to be the case. Okay, so how do you solve this? Well, what you need to do is you need to expand this. Okay, but if you look at this would keep on reducing the power of x, so this doesn't work. What can we do? That is why there are certain nuances to this rule that you have to be careful of. What if we took e to the power x as the first function? The utility of the e to the power x is that its derivative is also the same, so it can be equally useful as the first function as well. So that is sort of the confusion that comes with e to the power x. Let's try keeping that the first one. So e to the power x would be unchanged, and then there would be the integral of this. Now x to the power minus 2 integral would give x to the power minus 1. Okay, and there would be a minus 1 in the denominator. I'm not caring about the constants right now. E to the power x would be differentiated, and there would be e to the power x over here, and the second term is an integral of x to the power minus 2, which would make it x to the power minus 1. That is good. Why? Because you can do this again can do this part by parts again. You'll have e to the power x. Now what is the integral of x inverse? It is natural log of x. Okay, so you can just write natural log of x. The second term would be a slightly different term, e to the power x ln x dx. What would you do now? Because these can be a little problematic. Let's see what we can do. Is there a simple substitution we can use? Maybe ln x equals u du equals 1 over x dx. Nope, that would not do. So what can we do now? Maybe we can do it by parts again. So e to the x ln x, if we take the integral by parts, this time we'll keep the logarithmic one first. So ln x e to the x, what is the derivative of the natural log? It is of course 1 over x. So it's going to be x inverse e to the power x dx. Now what you can do is you can sub this over here, and then you can equate this with this and get the value for this, which is common in both of them. So you can find the value for this and you can sub this back and get the whole value. So the whole point is you need to use integration by parts a couple of times, more than a couple of times, to solve this one. I'm not doing these completely because I've done the previous questions, but this is just sort of a discussion, sort of a thing regarding these questions.